Hi there. In this video, we're going to talk now about gathering data, and specifically data from surveys or observational studies. Okay, so that's different from an experiment, say, where subjects are, doing a special diet or taking a drug. So this is purely observational. So surveys and observational studies. In an observational study, researchers gather data without interacting with the subjects. So there's not a treatment that someone's doing. And we cannot infer causation in this type of situation. It's purely observational. Okay, so we're going to talk about several different sampling methods. And as an example, I'm going to use, let's say we want to survey PCC students on how much they pay for housing per month and give an example of each type. So in the first column, we have our methods of sampling, getting a random sample. And then a second column, we have the description. And then the third, I'm going to use that example. So I'm going to write PCC students above that example column. Okay, so our first method is census, and you might recognize this from the US Census, where the government tries its best, does its due diligence to collect data from everyone. And so that's what a census means. It means ask the whole population. Ask everybody in the target population. Okay, now as you can imagine, this is difficult. This is challenging. It's hard to reach everyone. You could spend a lot of time and maybe even a lot of money trying to do this. Okay, so in the PCC example, we would need to ask every PCC student, survey every PCC student. And it's not enough just to have an email blast, because then you're not getting a census. You have to really do follow-up in order to ensure that you're getting a census. So email blast is not enough. Follow-up is key. Okay, and that's what they do in the census. First, they try to get everyone to do it on their own, and then they hire people to go and visit people who have not responded. Okay, still doesn't mean it's perfect, and you may not ever have a perfect census. You always have some. We'll talk about types of bias in the next video, but you have made a concerted effort to get the entire population. Okay, so that is a census. The next one is a simple random sample, and you may have heard about this. This is choosing subjects at random, kind of like drawing names out of a hat. Okay, so I'm going to say choosing subjects at random. Okay, it must be random with a computer or drawing out of a hat or something. So we could say random number generator. Or drawing from a hat. Or a box, anything like that. Okay, so what is an example of this with PCC students? Let's say we want to get 1,000 students. So let's say we want a simple random sample. And we'll talk more about sample size later in the class. Let's say we want a simple random sample of 1,000 students. So what we might do, we need to choose an identifier. We might write a computer program to select 1,000 random G numbers. Okay, and then we would send a survey to those students or contact them by phone. Again, follow-up is key to make sure we get all of those students who were selected. And yeah, I won't go into more depth on that. Okay, so stratified, simple random sample is great. But as you can imagine, let's say at PCC we have 4 campuses, right? 4 main campuses. What if for some reason a majority of the students were all chosen from Southeast Campus, which is the smallest campus? So things like that could happen. So there are some additional methods just to give that little extra way of making sure that you're getting a representative sample. Okay. So stratified is one of those. So I'm going to draw a picture. Let's say our population is a circle, and then I'm going to divide it into 4 campuses. And then what we could do is take a random sample inside each group, and that's called stratified. Okay, so what you do with stratified is you divide your population into groups. Usually it's a natural division. Okay, so divide into groups. And these are usually different groups, meaning they're more different from each other than similar to each other. And then we want to select randomly, all these are random, randomly select some from each group. Okay, so that's stratified. You can also think of strata. Strata is a word that means layers. So you could think of it as layers as well. Some from each layer, like that. Okay, so I mentioned the campuses. So we could divide by campus. And randomly select. Now, this is interesting. Would we want to take 250 from each campus? That's one way to do it. Or we could select a size proportional to the size of the campus. In other words, bigger campuses, Sylvania and Rock Creek, we might select more students from, and the smaller campuses, Cascade and Southeast, select a little bit fewer from. So that's another way, is it can be proportional to the size of the group. Okay. So I'm going to write randomly select some from each. Then I'm going to say may be proportional to the size of the group. Oops, dropped my pen. Okay. So here we go. Now cluster is another one. It's another different way, kind of like stratified, but it's a different way. This is when you have, I'm going to put many little groups here. If you naturally in your population have small groups, then what you might want to do is randomly select a few of those groups and survey everyone in those groups. So stratified and cluster get mixed up sometimes. Stratified is some from every group, and cluster is everyone from some groups. They're kind of opposite like that. So let me write it out, and hopefully that'll help. Divide the population into groups. It's usually a natural division like campus or classroom or something like that. Now this works more for similar groups. Okay, so this might be CRNs, like particular classes. Divide the population into groups that are similar. Randomly select a number of groups and survey everyone. Everyone in those groups. I'm going to say in those groups. Okay, so in the PCC example, I'm going to also just shade in a couple that show that I'm surveying the whole group. I'm going to shade in a few of these squares. I have many small squares, and I'm shading in a few to indicate that I'm going to survey everyone in those squares. Okay, so a good example of this is CRNs, or a class. So let's say we want to select 20 random CRNs. And then we can give the instructor all the surveys and have them give the survey to their whole class. Survey all students in those classes. This is a really good method for PCC or another school because, it's best to survey people when they are there and it's kind of hard to get a hold of people and get good response rate when they're not there. So a cluster could be a good one, especially if you're thinking in-person classes, but also could be put into an online class or something like that. Okay, so we've got simple random sample, stratified, and cluster. We've got two more. The next one is systematic. So this is another way besides just a simple random sample. Systematic works if you have a line or a list. So I'm going to say good for a line or a list. And then what we're going to do is, in this line or list, choose a random starting point and then survey every nth person after that, or auto part, or whatever it is, every nth subject. So choose a random starting point. Then select every nth, meaning we can choose a number here, like every 10th, every 100th, every 50th. Depends on the length of our list and how many we want to survey. Every nth subject. Okay, so let's say we have a line here. I'm going to draw this one over here to the right so I have more space. Draw a line of dots so that to indicate that I have a line or a list. And maybe randomly we choose the second as a starting point, and then I'm going to go every third after that. So I'm going to go 1, 2, 3 and circle that one, 1, 2, 3 and circle that one, 1, 2, 3 and circle that one, and so forth. Now this could be a physical line where let's say people are lined up for a concert and you ask people in line, or what was the one I was just thinking of? Oh, I forgot it. Hopefully it'll come back to me. So for PCC, maybe there's a line in the bookstore. So ask every 5th student in line at the bookstore The one I thought of was a manufacturing line. So this would be a really good one for a manufacturing line. You've got parts. Let's say you've got boxes of cereal coming off a production line, and you want to make sure they have the right weight. And so maybe you take every 100th one off, okay, and measure it. Okay. We could also think of, if we had G numbers in a list, maybe select every 50th G number. Okay, so that is systematic. So you'll get some practice in the homework with identifying. You'll be given a scenario and you can practice identifying the difference between simple random sample, stratified, cluster, and systematic. And then, of course, census, which is every one. And the last one is multi-stage. So multi-stage means we're going to combine any of the above, okay? So it's not a new method, it's a combo. Combining any of the above methods. Okay, so as an example, and we've actually done this for a campus climate survey because it's really important to get a representative sample, and we'll talk about representative sample in a minute on the next video. But what's an outside survey company came in, and what they did was first they stratified by campus. So they chose a number of CRNs from each campus. So I'm going to write first stratify by campus. And choose some CRNs from each campus. Again, probably proportional to the size of the campus, and also maybe we include some online CRNs in the proportions. That could be a fifth group, fifth strata. That would be good to do. Another way you could stratify is like day classes versus evening. There's another way to stratify. So this is one way to stratify. And then, so that's stratified, and then survey all students in those classes. So that's a cluster. Okay, so that's a combination of stratified and cluster sampling. Great, so those are all the sampling methods that we're going to practice and study in this class. And in the next video, we'll talk about a representative sample and types of bias. Okay, so I'll see you in the next video.